Good afternoon. Thanks for being here for this new presentation on open data latency. I'm from Whitehorse, Yukon. I'm a public finance economist, also a credentialed evaluator, and I work across different areas: quantitative data, qualitative data, sort of big data, everything in between. This is kind of an idea that I thought up back in July when the call came out for proposals, and I thought I should explore this a little bit more, so here we go. So in terms of an outline, we'll take a look at open data, what it is to start, and then we'll move on to the idea of open data latency. So the federal definition of open data is structured data that is machine readable, freely shared, used, and built on without restrictions. So I'm not sure about the grammar in that, but the key parts are that it's structured and machine readable. And also want to note that for it to be open data, it doesn't have to come from a portal. It can just be on a website. And I think often, in my work anyways, we often get stuck early on the structured part of data, of open data. So just a bit of a description, kind of top of mind, that structured data is consistent and fixed in format. It can contain alphanumeric data listed in columns with field or variable names in the first row, and the subsequent rows are called records. The records may contain nulls, so they may be blank. Text labels may repeat in some columns if it's truly machine readable. It contains no nested data, and it contains no totals or other numerical summarization. And with all of that, it's machine readable. Requires no intervention by a human to be used, which has implications for AI. So structured data is not the same thing as structured information. So an example of, structured information is this table from a publication from the Yukon Bureau of Statistics. So this is not data, it's summarized data. In the form of information. So it's not what we're talking about when we talk about structured data. And for our purposes today, I am talking about structured numeric data, so not qualitative data or text-based data. So a couple of examples around structured and machine-readable data. This is, I'm not going to download again, but this is data from the Bank of Canada, GBPP. This was the government bond purchase program. So this is from the Bank of Canada website, downloaded. This particular data series is actually the explanation for why we have inflation now. This is the record of, the open record of the Bank of Canada selling bonds to the government of Canada through the pandemic. So my question, is this machine readable and structured data in this form? I'd say it's close. So we've got in the top metadata in the first 32 roughly rows, right? And then when we get a little further down, we get into structured and machine readable data. So often, what's presented as structured data, machine-readable data, is not necessarily so. And then the second example is another one from Government of Yukon. think we've already been through that one. So let's move on then to the difference between static and dynamic open data. So static data has a fixed column structure, and the volume of data, or the number of rows, is constant or changes infrequently. Some examples of that are addresses and phone numbers, historical population counts, land areas. So that's, again, static data. For data to be dynamic, again, it's got a fixed column structure. The volume of data, the number of rows, is expanding in real time. So we're adding to that data series with that same fixed column structure. Some examples here are share prices, air temperature, Internet of Things data, like my watch. Apple Watch is tracking all kinds of stuff. So then on to the idea of open data latency. As I mentioned, this is sort of just an idea that I had, so I started, of course, with Google and discovered that the idea of open data latency, at least back in July, didn't exist on Google. I'm not sure if it does now, but this is really what I want to get into with the presentation, is the idea of taking together the idea of open data and adding to it the idea of latency. So the continuum that I've devised for open data latency, going from static to dynamic, is starting on the left with static data, historical or tombstone data. Then as we move towards more dynamic data, we're talking about bulk or union data. And then the third stop on the continuum is pull data. And then the most dynamic version of open data is push data. So we'll work through these four cases. And really what distinguishes each of those cases is how quickly is the data refreshed, and secondly, how quickly is the application refreshed. So we'll see with historical that refreshing happens rarely for both the data and the application. For bulk, it's refreshed when there's a new union and when there's a new load into an application. Third, pull, the data is refreshed constantly. It's a data stream coming into a database, but the application isn't refreshed until the application reaches into the data and pulls data out and visualizes or some other way of representing what's in that data. And then push, data is streaming into a database and then streaming straight back out. So historical or tombstone data is familiar with sort of the last record, often in some kind of a data portal that got set up years ago. And so it's data that it's perfectly fine, it's structured, machine readable. It's just never been updated in years since it was uploaded to that particular portal. So again, data that in a historical sense is rarely refreshed, and the application is rarely refreshed as well. So bulk data is the next step along the continuum. And I see this often in Excel spreadsheets where I've got different years of data in tabs in a sheet. So again, it could be properly structured, could be in machine readable format, but it's discontinuous. So bulk is really just the idea of taking a structured data set and adding more rows to it. Okay, and so in this case, it's not in a continuous sense, it's sort of in a manual sense, so you're adding as you go. So the example in the bottom half there, I don't know if it's familiar to folks, that's a screenshot out of Tableau Prep. So that's the tool that goes together with Tableau to do data cleaning and data manipulation. So one of the functions of Tableau Prep is being able to write a script to do a union. So, and again, a union is distinct from a join. We're not talking about joining data sets, we're talking about adding data in a union. So yeah, just the refresh there, new union, new load. Okay. So sometimes in these presentations you get told to put your phone away, turn it off. I want to do the opposite here. I need you guys to get your phones out and tap in here. Okay, and you should have a short survey coming up. Oh, sorry. Good. Okay, so the first question is asking you for a respondent code. That's on the back of the sticker that you should all have. Okay, so you're filling in a Google form. So that data is coming through Google Form into a Google Sheet. Okay, so as you're hitting submit, you're adding to that data set, but it's streaming, right? It's streaming into that data set. Okay, so I spent the last couple of days debating whether or not I should do this part of it live. I'm going to, in the end, because I haven't seen a lot of visualizations at this conference. Last year in Whitehorse, I think we had more. And I kind of have a thing for live, so we'll try this. So I'm just loading up Tableau Online. I'm going to set up a fresh workbook here. Okay, so by live, I really mean like I'm starting from scratch. Like I don't have I do have a backup version of this, but I'm going to start from scratch because I think sort of together with open data latency, there's a latency challenge sometimes with visualization. Like it doesn't need to be a sort of a different step, doesn't need to be a different person, that can all be sort of together in real time. So this is a real-time example of a visualization. So. Now, are folks at all familiar with Tableau? Anybody in the room? Tableau user? Couple? Okay, so yeah, Tableau is meant to be intuitive and quick. So there's a visualization of one of the questions on that survey. So I'm glad to see that most people are having an awesome day. For the person having a terrible day, I don't know what to say, but hopefully it'll get better. Okay, so here's just a quick visualization for what people wanted to be when they grow up. So I include an open-ended question sort of just as proof that this is actually live. So hopefully you're seeing your responses in there. Tableau Online for some reason is really small on screen, so astronauts. Okay. So here's our example of pull data, starting data streaming in. So next, I'll just do those two visualizations, but next I want you to go back to your phones and redo that same survey. Okay, and so again, you can see streaming data. This is the Google Sheet. And people are being honest about whether it's the first or the second time, it looks like. Okay, so now we've got streaming data. Let's go back to, oops, our Tableau. So we've got data streaming into the database. The idea of pull now is that I'm going to reach in to that database. I'm first going to add that. So when I hit refresh, that visualization will update, right? So that's what I mean by streaming data. This is the pull case. Streaming data builds up, then I reach in and I pull it out with a refresh of the data set. Okay, so this I think is the most familiar use case for open data. Great, so then just to recap on that, how quickly is the data refreshed? It's in a stream, and the application is refreshed with a new load. So reaching in and pulling out. Okay, the fourth case is push. So again, here's a different kind of visualization of that. Batch processing here is represented as pull. So this idea of data accumulating in a database, and then there's a new kind of issuing of that data, there's processing, and the results come off of that. Push is, it's real time. So the data is accumulating in real time, it's being processed in real time, and the live results are being presented in real time. So this idea of push is also known as streaming ETL. So streaming, extract, transform, and load. That's that idea of continuous processing, sometimes referred to as the data fire hose. So this is where the Skynet kind of joke fits, that AI will want not the tombstone data, not the bulk data, not the pull data, but the push data where it can get it in the context of Skynet. Along the way, I've discovered not everybody knows what Skynet is, so here was ChatGPT's answer to what was Skynet. So from a movie, 1984, Terminator, Skynet was the AI villain. I wear a couple different hats in Yukon. One of them is actually doing live sound mixing. So this is Dawson City Music Festival in July of 2023. The band on stage is called Diamond Dino. But live sound has gone digital. It's push. So the yellow arrow is pointing to an Ethernet cable. That's what's connecting me on that mixing board to the sound happening on stage. It's coming to me digitally, and I'm sending it back digitally to the speakers on the side of the stage. So just as a point of reference, that this idea of streaming data being used in a push sense, like streaming, is familiar in other contexts. So live sound is one of them. So if it seems, that moving from pull to push is sort of an impossibility, there are, other examples out there of where data is happening, how it's being used in that way. Okay, so another example, another Google form. If you guys want to get your phones again and bring that one up, please. Is that one working? Yep, great. Fascinated by QR codes. Like how you can be 30 feet away and it still works. Okay, so a couple questions. In there, this is within Google Form, so apologies for the size of the fonts in there. Maybe I can get that a bit bigger. So yeah, just a little interesting question on where we're at and where people think we should be going. Okay, so I invite you to do that same survey one more time, please, and keep an eye on the screen. So here we've got streaming data coming in, and Google Form is pushing it out as fast as you guys are hitting submit on your phone. So that's an example of our fourth case. Okay, and then yeah, just a recap. So streaming data in, streaming data out. And that brings me to the end of that part of it. There's one piece at the very end, but I'm going to ask if there's any questions first before I move on to that. Comments or... Yeah, okay. No, I can see that for sure. It's dependent on the type of data that you're working with, for sure. Yeah.
Is there ever any desire to incorporate QA space in there, and particularly around open text fields? You have one in your survey, people putting things that they should put in there.
Mhm. Oh. Yeah, I'll maybe get you to ask your question again.
Thanks. Yeah, I was just asking if there was ever a need to put a QA gate in there, a quality assurance, just to make sure that in the case of, or changing your data design in the case of a pull or a push, sorry, the most dynamic, that you don't end up with things in an open text field, for example, that people shouldn't be showing in there, and you don't want to.
Yes, yeah. Yeah, we'd want to have some capability there. Thought about that a bit. Was reminded of some software called Poll Everywhere, which is basically the same idea as a Google form and visualizing in real time. But they actually had you could restrict certain words from showing up because it's true. Like I've used Poll Everywhere as part of an economic impact study and polling people. It was an economic impact of a film festival. So polling people in the audience at the end, at the beginning and the end of the film. And so, you know, a theater with 400 people, you never know what's going to come up. So, yeah. But yeah, no, it's a good question. It'd definitely be a necessary part of it. Yeah. Okay. Any further questions? Okay, on to the last bit. And so I need to ask my assistant, what was the highest number that we got to?
31.
Okay. So, does everybody have a sticker with a number on it? We're all good. Okay, so it's Friday afternoon. Just for fun, I'm going to do a couple of draws. It's a pair of Edward Tufte visualization books. So this first one, the first draw will do Tufte's first visual display of quantitative information. So if you see your number on the screen, just come on up and grab your book. There we go. No. Great, you're welcome. Okay, the second one is Tufte's latest, Seeing with Fresh Eyes, Meaning Space Data Truth. And here we go again. Other side of the room. Not in the room. Okay, I'll maybe run that again.